Okay, let's talk about PARCA Technical Section 5.2, which covers local area network, wide area network, wireless connections, CMSA-CD, FDDI, and Class A, B, and C networks. LAN stands for Local Area Network. A local area network is a private network that facilitates members of a closed group to share information. It's a collection of devices connected together in one physical location, such as a building, office, or home. When you come home, your phone probably connects to your home network, and that's a LAN, right? It's a private network just for the devices and people inside your house. WAN stands for Wide Area Network. A wide area network is a network that spans large geographical distances and often connects different LANs. In its simplest form, a wide area network is a collection of local area networks or other networks that communicate with one another. A WAN is essentially a network of networks, and the internet is the world's largest WAN. So in your house, on your street, in your community, in your neighborhood, if each home or apartment or townhouse is its own LAN, all of those together form a WAN, a wide area network. Wireless connections. So a WLAN stands for Wireless Local Area Network. And IEEE 802.11 is the standard for wireless network connections. Carrier Sense Multiple Access is a network protocol that listens to or senses network signals on the carrier medium before transmitting any data. It's implemented to Ethernet networks from more than one computer or network device attached to it as part of media access control. CMSA is like a traffic cop or stoplight, right? So at some point, even a wireless network, you connect the wireless router. The wireless router has a cable which connects it to the modem or to the wall, right? So even in a wireless network, at some point, it has to become a wired connection and data travels along those wires. There has to be some sort of flow control system, so the traffic flows one way and then traffic flows the other way. So you can download your cat videos from the internet and then upload pictures of your cat onto the internet. CSMA is what provides the stoplight traffic cop. These signals can go this way, those signals can go that way. It provides that direction and flow control so that we try to avoid collision detections. However, in networks, collision detection happens. So collisions occur on most networks, and so there's a protocol to recover when collisions happen, when the data packets bump into each other and get stuck, and that's what CD is. CD stands for collision detection. So Ethernet uses CMSA-CD as its collision detection and recovery system. FDDI, Fiber Distributed Data Interface, is a network standard that uses fiber optic connections in a local area network that can extend in a range up to 200 kilometers, which is 124 miles. So keep in mind, for FDDI, we're talking about a LAN, a private local network, but one that is so big it needs to cover miles. For example, let's say you work for Penn Medicine and you have a hospital in Lancaster, but you have a women's imaging center or an outpatient clinic in Reading. And you want all of the radiology devices in those two buildings to be on a local area network, so they only talk to each other. So all of that data traffic stays within a local area network specific to radiology. It's just that the buildings are far apart. That's when you use FDDI. It extends that range over fiber optic connections, so you can have a LAN that is in a large geographical area. Then we have Class A, B, and C networks. So a Class A network uses the default subnet mask of 255.0.0.0, and it has 0 to 127 as its first octet. So if you don't remember what an octet is, the first set of numbers is the first octet, the second set of numbers is the second octet, third octet, fourth octet. So in a Class A network, the first octet has to be between 0 and 127. So 10, 52, 36, 11, first octet is 10, which is between 1 and 126. Class B networks uses default subnet mask of 255.255.0.0, and they have 128 to 191 as their first octet. So an address of 172.16.50.263 is a Class B address. The first octet is 172, which is between 128 and 191. Class C networks use a default subnet mask of 255.255.255.0, and they have 192 to 123 as their first octet. So the address 192.168.123.132 is a Class C address. Its first octet is 192, which is between 192 and 223. So, two important things to tell Class A, B, and C networks apart. So, talking only about the subnet mask, a Class A uses 255. It only uses the first octet in the subnet mask. Class B uses the first two octets in their subnet mask. Class C uses the first three octets, 255, 255, in the subnet mask. So if you only look at the subnet mask IP address, that's an easy way to tell a Class A, B, and C network apart. Or you could remember that in a Class A network, the first octet is 1 to 126. In Class B, it's 128 to 191. And Class C is 192 to 223. So that range of the first octet tells you whether it's a Class A, B, and C network. So that's all about Class A, B, C networks. Thank you for watching.